All right, everybody, these are going to be the lab instructions for the 6.2 Avogadro's number lab. This lab is super easy, super quick, no goggles required. You just need to have some lab supplies. So you'll need the test tube rack. It needs to be empty. Make sure that you don't leave test tubes on the counter to roll off. You'll need a pencil, go find your own. You'll need a scale. And then in your drawer, you need to find a 250 milliliter beaker, like this. And you also need to find a glass stir rod. This should be in the top drawer, looks like this. Now you need to weigh each one of these items and write down their masses in your lab. Now when you're measuring the mass, a couple things you need to verify. It should say G at the top of the screen somewhere. Also, when you turn it on and there's nothing on it, it should say 0 and not fluctuate. If this doesn't say G, hit the M to change the mode of measurement. Continue clicking until you get to the G you're looking for. Not GN, just G. Additionally, if you only have one decimal point here, if you only have one number after the decimal, you could consider switching to a different scale that's a little bit more accurate. That will help. If you put something on the scale and then you hit the T, you're gonna lose your information. If you do that accidentally, just remove the item, tear it again, and then you can measure your mass. Once you have a mass, make sure you write it down in your data section here on your lab paper. So 10.53 is my number. It's okay if yours is different. This should be a little bit unique to your own supplies. For example, the green test tube racks might weigh differently than the brown ones. Now, I chose these items for you to investigate for a specific reason. If we look here, we have two small items that are made of glass and wood. And then we have two big items that are made of glass and wood. Now looking at these, obviously this is much larger than this, and it weighs more. It weighs almost double the beaker. But it's the opposite situation here. These are close to the same size, but the glass stir rod weighs about double the pencil. Again, one more time. This piece of wood is double that, but this piece of wood is half of that. So we're talking in halves and wholes here. Now I'm gonna generalize my data a little bit so we can see this kind of pattern. This is double that, and this is double that. Now comparing the sizes, these are the same size, but different masses. And then over here, these are different sizes and different masses. So we can compare volume and mass and relationships of the chemicals through each one of these relationships. All right, now that we have our data I generalized here, we can start filling in the beginning of these conversions. Now what's nice is we have these conversion cards to help us go from things like grams into what they're asking for, atoms. So let's play that out. In order for us to go from grams to something else, we have to use this green card. This pink card doesn't have grams on it. It has moles, atoms, here's moles, here's grams. So for me to get out of grams, I have to divide by grams in my next fraction. Now this is good, but it doesn't get us into atoms like we're looking for. It gets us into moles. And so we're gonna have to convert again. And I need to pick the side of this card that shows moles on the bottom. We have to divide by the thing we're currently in. That way they can cancel out. If I take 1 and I divide by 1, I get 1. If I take moles and I divide by moles, I get 1. Wild stuff. So we need to do these types of conversions for these sections. But what number should I start with? Well, we should start with the mass we have. So the glass stir rod we measured was somewhere around 10 grams. I need to get out of grams and into something else. Now, I don't have anything that goes grams to atoms, but I do have grams to moles, just like you guys did on the test. Now, what exactly is this conversion? Well, in 1 mole of something, we have a molar mass. We have a mass, grams, per 1 mole of something. So you'll have to calculate the molar mass of this here. Now we're in moles of silicon dioxide. We need to get out of moles and into something else. SiO2, there we go. Now again, we're trying to get into atoms, right? That's what we're ending in. So I have to have atoms on the top of my last fraction. And what do you know? I have a fraction that is moles to atoms, and then it tells me the numbers I need. I need to have 1 mole of silicon dioxide, and whatever that thing is 6.02 times 10 to the 23rd atoms. Okay, So we have our conversion set up. We just need this number down here. Again, you have to calculate the molar mass of silicon dioxide. What's nice though is whatever mass you get right here is also going to go right here, because this is also made of silicon dioxide. You should have a different number here, and you should have a different number here. You'll have to calculate the molar mass of wood instead of glass. Now by the end over here, keep careful track of your exponents. Right now I'm in 10 to the 23rd, but that might change, so use your calculator carefully. I recommend using Desmos scientific calculator if that is something you can access on your Chromebook. Once you have this filled out, you can start getting into your conclusion. We're going to be comparing these quantities over here and seeing if they match our predictions from the pre-lab. Now getting into our conclusion, when we're comparing the 250 milliliter beaker, so that would be the one right here, and the test tube rack, this one, which one has more atoms? So we're comparing these two values right here. Which one is bigger? Which one has more atoms? And then which one has more mass, right? So if we go back, we're starting with 100-ish is the mass of the beaker, and so that's the number that's going in right here. And then the test tube rack is 200-ish. So from that information, we know the test tube rack has more mass. But which one has more atoms? Is it matching? Is this rack going to have more atoms, or is this going to have more atoms? If this matches your prediction, you'll be able to explain why using the same argument that you had back here. But if you were wrong, you're going to have to explain how it works. You're going to have to explain why this is not what you expected it to be. You can do that by using this section here. Now, usually when we have a conclusion, the first question will be your claim. The second one is usually your evidence, and it's no exception here. What you're talking about, what you're trying to do in this second question becomes your evidence for the next section, for your CER. So, read this carefully. Which equation started with more mass? Highlight that number. So looking at these equations, which one is starting with the bigger amount of mass? Which molar mass was larger? So this fraction right here, the green conversion card, this is molar mass. So which number is bigger for the grams for these two sections? Highlight that number. Next, which atom is larger? So which answer at the end is larger? You'll want to highlight that. And then C, compare those relationships. What exactly is happening on a mathematic level, right? We're starting with 200, but then we're dividing by 28. What does that number kind of look like? Is it big? Is it small? Is it bigger or smaller than 100 divided by 12? If you don't know the answer, that's okay. Put it into your calculator and see. Take this time to compare. Really look at the math and try to understand what's happening. Damn, because these are the same, right? So what matters is what's happening in this part, and that's going to have a big effect on the end. And with that, you should be able to complete your lab and write the CER. Have fun.